Displacement, velocity, and acceleration. Displacement. We've covered distance. Distance is a measure of how far an object traveled, but does not indicate how much of an object's position has changed during a time interval, nor what direction that it moved. For instance, it could have gone out and come back again. In that case, it has traveled a distance, but it has not changed its position. The final position equals the initial position. Displacement describes the amount that an object's position has changed during a time, as well as the direction of that change. If the displacement is along the x-axis, the object's position is x, and the change in its position, its displacement, is delta x. The symbol for change is the Greek letter delta. Henceforth, that's called delta x. Displacement describes how far you are from where you started, regardless of how you got there. For instance, if you drive 60 miles from Pennsylvania to New Jersey, and that's heading east, by the way, we represent it here on this graph. We have the plus x direction there, minus this way, and we have 6 units there. Each one would be 10 miles. And in physics, we label the starting position x0. Could also be x initial. People use different criteria there. So we've represented your motion from Pennsylvania to New Jersey. Then you drive 20 miles back to Pennsylvania. So you started here where you were in New Jersey, and then you came right back this way 20 miles. And we label that final position x sub f, f for final. Now, you have traveled a distance of 80 miles. That's what your speedometer would register. You went 60 out and 20 back. 60 plus 20 is 80. However, you only had a displacement of 40 miles. That is how far you are from where you started. We calculate displacement by delta x is equal to x sub f minus x sub 0. Now, measurements of distance can only be positive values or magnitudes, since it is impossible to travel a negative distance. Imagine trying to measure a negative length with a meter stick or half a meter stick. However, your displacement can be positive or negative, since you can end up to the right or left of where you started. In this case, you started here at the 3rd mark, you wound up at the 5th. So you have x final minus x sub 0, that gives you a positive number. Your displacement is positive, or to the right. Or in the case of the Jersey traveling, your displacement would be to the east. In this case, you started here at 3 marks out and came into 1. So in that case, your displacement is negative, or to the left. Speed is the distance traveled per unit of time, right here. Velocity is a displacement of an object, delta x, per unit of time, delta t. Now we use t and delta t interchangeably sometimes. Delta is probably better to use because it shows the change in time. T is if you start your time at t equals 0, which we will do most of the time. But going forward, we'll use delta t. Time is not considered to have a direction, just an amount. Since distance and time are always positive, speed is always positive. But since displacement can be positive or negative, velocity has a magnitude and a direction. It can be either positive or negative. Average velocity. Sometime during an object's motion, its velocity will change. For instance, if you're driving to the grocery store, there may be a highway where the car travels quickly, and there may be stop signs where the car's velocity is 0. The average velocity for the trip can be found by dividing the total displacement by the elapsed time. The average velocity can be positive, negative, or 0, depending on the motion with respect to the starting point. So if you start here at your home, go shopping, come back, your displacement is 0, and so is your average velocity. We then have instantaneous velocity. The average velocity does not tell us the velocity at every moment in time. It's just the average for the entire trip. So let's think about the trip to the grocery store. When the car stops at a stop sign, its instantaneous velocity is 0. The instantaneous velocity is the velocity of an object at any brief moment in time. That's what you would read off your speedometer in the vehicle. Mathematically, the instantaneous velocity is delta x over delta t, which is our definition, but we let delta t get vanishingly small. We let it approach 0 to get that instantaneous moment of time. The instantaneous velocity can also be positive, negative, or 0 depending on the motion. Let's work an example. After a time of 7.0 seconds, a car traveling at a constant velocity is located 21 meters east of its original location. What was its velocity? Please give it a try, and we'll show the answer on the next slide. Our givens are 7 seconds of elapsed time, delta x is 21 meters, and we'd like to find the velocity. We will use east as the positive direction. That's pretty common in kinematics. We have our velocity equation, we put in our numbers, and notice we put plus 21 meters just to make sure we know it's positive and to the right. Here's our time. We get an answer of plus 3 meters per second. And our final answer will be 3 meters per second east. Notice we have a direction there. This is a vector. The answer does not include the plus sign. Rather, that is interpreted to provide the direction east. A car travels west at a constant velocity of 22 meters per second for 12 seconds. What is its displacement during that time? Answer is on the next slide. We have our givens, and we put a negative sign on the velocity because we assume west is a negative direction. Our elapsed time is 12 seconds, and we want to find the velocity. So we have v is delta x over delta t. We want to rearrange that to solve for x, so we multiply both sides by delta t. And then we switch it around, so we have delta x is v delta t. Plug in our numbers, and you get negative 264 meters. But our answer will be 264 meters west. We take the negative sign out, and we interpret that as west. Acceleration is the rate of change of velocity. So that's delta v divided by delta t, or v sub final minus v sub 0 over delta t. It is the change in velocity over elapsed time. Acceleration is a vector. Although in one-dimensional motion, which is what we're doing here, we only need the sign. Since only constant acceleration will be considered, there is no need to differentiate between average and instantaneous acceleration. They are one and the same. You can derive the units by subtracting the correct units into the right-hand side of these equations here. So we have velocity, meters per second, times seconds. And then what are we doing here? We still have meters per second here, but we put s over 1, right? Because s over 1 is equal to s. We then have m over s, meters per second. And then when you divide by s over 1, you're multiplying by 1 over s. And you multiply it and you get m over s squared, or meters per second squared. A car changes its velocity from 4 meters per second east to 8 meters per second east in 8 seconds. What was its acceleration? Answer on the next slide. We start with our givens, and we put a plus sign on both the velocities because we're going to assume east is the positive direction. Here's our equation for acceleration. We put in our numbers, plus 8, final velocity, plus 4, initial velocity. Carry out the math, and we get an acceleration of 0.50 meters per second squared. But we write our answer as 0.50 meters per second squared east. We interpret the positive sign as meaning east. A car, starting from rest, accelerates at 2.4 meters per second squared to the east. What is its velocity after 15 seconds? So in the beginning, we have a vehicle at rest, a car at rest, so its velocity is 0. It accelerates at 2.4 meters per second squared for a time of 15 seconds. What's its final velocity? Once again, we'll say east is the positive direction. We have our equation there. We substitute in Vf minus V0 for delta V. We multiply both sides by delta t, and then we add V0 on both sides, and we come up with this equation here, which later on as you study physics, you'll find out that's the first kinematics equation. We now substitute in our variables, 0 initial speed, here's our final speed, here's the time, and we come up with the final velocity of 36 meters per second, and since we have a positive number, we call that east.